So we've talked about graphing rational functions a little bit. We talked about the vertical and horizontal asymptotes. And so when I go to graph one on my own here, that's what I'm going to start with. I'm going to start with those asymptotes, finding the asymptotes for my rational function here. And so once again, I'm talking about the vertical asymptote. Well, for one such as this, that's going to be where the denominator equals 0. And so I just set that equal to 0. And solve that out. And that's going to be positive 3/2, 1.5. All right, then we also mentioned, for ones like this, horizontal asymptote. And if you recall there, to get the horizontal asymptote, if your degrees match like they do here, the degree of the top equals the degree of the bottom, we're just going to do a little equation, y equals a over b, where a and b, those are the leading terms of the top and the bottom. And so in this case, the leading term on top is 6x, bottom is negative 2x, and so of course the x's cancel. And we get negative 3. So the horizontal asymptote is y equals negative 3. And when we go to graphing this then, what we're going to put those in as, those are just, we're going to just draw those in as dotted lines, and then we'll discuss what happens with them when we get some more points on here. Okay, so the vertical asymptote is 3/2, which is 1.5, which is here. So we're just going to put a vertical dotted line through 3/2. X is 3/2, 1.5. And then a horizontal asymptote, so that's going to be a horizontal line at negative 3. The y value negative 3. Like I said, we'll discuss more about what that will mean to the graph here in a second. All right, the other things that can help us as far as graphing here, because that's really not any points, that's just reference lines, I guess you might call them. But what else can help us here are the intercepts. And good news, we've already done intercepts before. Basically the same thing as always. To find the y-intercept, you just set x to be 0. And it's for others as well as this one, so that doesn't change. To find the y-intercept, you just set x to be 0. So it'd be y equals x is 0, so it'd be 6 times 0 over negative 2 times 0 plus 3. So that's 0 and that's 0, so it'd be 8/3. Or 2 2/3, or some, they're equivalent to that. All right. And then the x-intercept, said it's the same as always. We find the x-intercept by, how do we find the x-intercept? Y to 0. Which in this case, instead of y, we've got f of x. F of x is 0. That's the thing that stands for the y here. So it'd be 0 equals 6x plus 8 over negative 2x plus 3. Which looks a little more complicated, but it is not really, because if I multiply both sides by negative 2x plus 3, to get rid of that denominator there, well, that's 0 times negative 2x plus 3, that's still 0. So you wind up with just 0 equals 6x plus 8, which is, solve that out, x would be negative 8 over 6, so that's negative 4/3 and negative 1 1/3, or something equivalent. With me there? Almost, okay. All right, so putting those points on here, those are the intercepts. So the y-intercept's 2 2/3. That's where it crosses the y-axis. 2 2/3. The x-intercepts where it crosses the y-axis, so that's -1 1/3. Well, that gives me some good information, but there's still a little more that we may need to find out here. So here's what I suggest. We kind of need to know what is happening around the vertical asymptote. We looked at one last time, but let's get a few details more about what's happening around that vertical asymptote. Let's just do a table of values with values around the vertical asymptote. Which in this case is 3/2. X equals 3/2. And so what I mean by that, maybe a couple on the left and a couple on the right. Kind of close, nearby that 3/2. Well, good news is I've already kind of got, I do have one already close to the 3/2. I've got x is 0 locked up. So let's just do x is 1, because that's pretty close to 1/2, 1.5. And then on the other side, so that'll give me a couple on this side of the vertical asymptote. And so a couple more on the other side, maybe 2 and 3. So it's just getting a couple of values around, and that'll help us figure out a little more about what's going on here. All right, so if x is 1, what do we got? Plugging in x to be 1. So it'd be 6 times 1 plus 8 over -2 times 1 plus 3. You don't have to write all this out. I'm just showing you what I'm doing here. So that's going to be 6 plus 8 over -2 plus 3. So that's going to work out 14 over 1, 14. So 1 for x, 14 for y. Then let's go ahead and do 2 to 3. So same thing, and plug in x to be 2, so it'll be 12 plus 8 over -4 plus 3. So that's 20 over -1, that's -20. And then at x is 3, we've got 18 plus 8. And then -2 times 3, so it'll be -6 plus 3. With me there? 26 over -3, so that's a little over -8, -8.6 repeating or something like that, isn't it? Is that right? Check me on that. Is anybody checking me? Sure, I think that's right.
Yes, it is.
All right, thank you. Okay. So I've got 114. Put that up here. Where am I at? 4, 5, 6, 7, 8, 9, 10, 13, 14. There we go. So it's at 1 and 14. Then I've got 2 and -20. So x is 2, and then I've got -20. Way down here. So -4, 5, 6, 7, 8, 17, 18, 19, -20. There you are. So that's at 2. Is -20. And then 3 is not quite as far, it's only -8.6. So there's -8, I believe, and -8.6, we'll call it good right there. Okay, so here's how that helps me. What I saw was, on our previous work, was, yeah, that vertical asymptote, it's a vertical asymptote because that's where the denominator equals 0. And I can't cross that line because that would make the denominator 0, and that's not a defined expression. Something over 0, that's not a number. So my graph is not going to cross that vertical line there, and so one of the reasons we draw it in. The other thing was, what we saw was, what happens as I approach one side or the other of the vertical asymptote, it either goes up towards that vertical asymptote or it goes down towards the vertical asymptote. And that's what these points are going to help me with, because I can clearly see here that as I go towards this vertical asymptote, it's going up, isn't it? And so our graph is never going to cross that line, but it's headed upwards as we approach it on that side. Then on the other side, same deal, it's either going to go up or down towards that vertical asymptote. And so that's what these points tell me, seems to indicate that these are going down, aren't they? Okay? So we've got a little bit of it. Now the other thing, the reason we drew in the horizontal asymptote, remember what I said on that was the horizontal asymptote, what that tells us about the rational functions, that tells us about the end behavior. The horizontal asymptote gives us our end behavior for rational functions. It's what's going to happen, what's going to go to on the ends. All right, and so whatever happens in the middle here, on the ends, it's going to come close to this horizontal asymptote. So what that means is, to fill in the rest of this graph, if this is what's got to happen, it's got to come to this line on the ends. This point's got to come in, it's got to swoop, it's going to come on down and level off, and that's another way we can put it, the end behavior. That tells me where it's going to level off. This is where our graph is going to level off on the ends. Okay? To be even more descriptive, okay? The horizontal asymptote is where it levels off on the ends. So it comes from this point, I'm just going to connect it up and level it off on that horizontal asymptote. Same thing over here. This one's going to come in, of course it's coming up towards it, but it's going to level off at that horizontal asymptote. Okay? Make sense? So asymptotes, intercepts, and a couple other points. That's what you need on these. They are a little more complicated, but that's what they are. Question? Let's do another one. Try another. All right. This one's going to be f of x equals -5 over x plus 2 let's do the same, basically the same stuff on this. Asymptotes, intercepts, and a little table. Start with the vertical asymptote. Well, the vertical asymptote's easy. Denominator equals 0. That's x equals -2. Horizontal asymptote. Well, we've been saying y equals a over b. The little problem on this one is a over b, that's if the degrees are matching. And I don't have a degree matching here because on the bottom I've got an x, on the top I don't have an x, but we can fix that very easily and just say, let's make the top 0x. Which the x's have canceled, so you got 0 over 1. That's just 0. So the horizontal asymptote in this case is going to be 0. So let's go ahead and put those on the graph. We'll do our other stuff. We've got a -2. Vertical asymptote, then the horizontal asymptote is 0. Can't really necessarily see it, but we'll dot it in just for effect there. Okay. All right. Now what about my intercepts? What about the y-intercept? Well, the y-intercept, you set x to be 0, just like always. That gives us -5 over 0 plus 2. That's -5 halves, -2.5. The x-intercept, okay. Yeah, all right, so then something else happens on this. So the x-intercept, we set y to be 0, or f of x, in this case, to be 0. And so that gives us this equation. So again, if we do what we were doing before, multiply both sides by x plus 2, here's what we run into. That would cancel, and this side will be -5. But this side is 0. What do we got?
It's +5.
It cannot.
That's an equation that is false, isn't it? We've got a 0 equals just a number, -5. In other words, there's not an x there to solve for. That can't happen. there's no solution there. So what does that mean as far as x-intercept?
There's no.
There's no x-intercept. It's not going to cross the x-axis in this case.
That's where the asymptote is. The horizontal asymptote.
Right, right. You got horizontal asymptote at 0. That's. We'll talk about that though. You're talking about crossing the horizontal asymptote. Yeah, we'll talk about crossing the horizontal asymptote here in a second. All right, so there's no x-intercept. The y-intercept's -2.5. So we've just got 1 point. Yeah, so a table I think would be definitely helpful here. All right, so my suggestion for the table is just do a couple of points on either side of the vertical asymptote, okay? So we're going to choose x values around the vertical asymptote. So our vertical asymptote here is -2, so let's do, over here we've got maybe -4, -3, and then over here -1, and we've already got 0, so the reason I do a couple is so we can see the general direction we're going as we go towards the vertical asymptote. So if we just have 1, it doesn't really give us that much information so on either side. All right, so -4, we've got -5 over, just plugging x to be -4, -4 plus 2. So that's -5 over -2. That's positive 5 or 2.5. And -3, we've got -5 over -3 plus 2. So that's -5 over -1, which is positive 5. And then at x equals -1, we've got -5 over -1 plus 2. So that's -5 over 1, which is -5. Did I do those right? Believe that? So at -4, I am at 2.5. At -3, I'm at 5. At -1, I'm at -5. Like I said, with the 0, we've already got it marked. So, yeah. So what we know about vertical asymptotes, I think this should be sufficient because as we go towards the vertical asymptote here, again, it looks like that direction we're going is up towards that vertical asymptote. On the other side of the vertical asymptote, these points seem to indicate the direction is down. Yes? Fill out the rest of the graph. Well, the rest of the graph is sort of the end behavior thing because this pretty much tells us what's going on in the middle here. Yeah, the end behavior then, this gives us what happens on the ends. It's got to level off at 0, and so it's going to swoop down to 0 here, and then swoop up to 0 there. Yes? Good? Question? Good with that? Anything further?